We're going to review our triangle properties, which is going to be on your quiz today, or no, your quiz on either Tuesday or Wednesday, depending on if you're an A or B day class. So a lot of these things are not new. None of them are new. We've reviewed all of them last week. I just want to make sure you have a notes resource to keep them. So first, we're going to talk about classifying triangles by sides. An equilateral triangle has 3 congruent sides. All sides are congruent, and 3 congruent angles. All angles are congruent. So that also can be called equiangular. So equilateral means equal sides. Equiangular means equal angles. Isosceles triangles have 2 congruent sides that we call legs, and 2 congruent angles that we call base angles. Scalene triangles have no congruent sides. All 3 sides are different, and all 3 angles are different. So if you scroll over to the side, you have 6 different triangles to classify. You grab them and you drag them. I know this one has 3 congruent sides, so it has to be equilateral. This one has 1 tick mark on this side, 2 on this side, and 3 on the last side. So that means none of those are the same. That means this is a scalene triangle. And this triangle has 2 tick marks on both of these sides. So that means it's isosceles. It has 2 congruent sides. Okay, what I want you to do now is pause the video really quick and classify the other 3 triangles. Okay, hopefully you've classified those other 3 triangles now. And we're going to talk about classifying triangles by angles. Right triangles have one 90-degree angle, one right angle, which we know looks like a box, like this one. So this is a right triangle. Obtuse triangles have exactly one angle measuring greater than 90 degrees. One angle is more than a perfect corner. Acute triangles have all angles measuring less than 90. So every angle in the triangle is less than a perfect corner. Okay, we've already got one right triangle over here. Let's find an obtuse one. Well, this is open much wider than a perfect right angle corner. So that is probably obtuse. Right here, this is our obtuse angle. And this one has 3 angles, all less than a perfect corner. So this is going to be our acute triangle. Okay, pause again, sort your other 3 triangles, and then we'll talk about the triangle angle sum theorem. Okay, so we know that the sum of the 3 angles in a triangle is always 180 degrees. The 3 angles in any triangle add up to 180. So to find the missing angle in each triangle, we want to add up the 3 angles and set them equal to 180. Then we'll solve for the missing angle. So here we would have 35. I know this box means this is a 90-degree angle, plus x equals 180. Now we know 35 and 90 together equals 125. You have your calculator on Desmos if you want to check me. And that equals 180. Finally, we would have to subtract 125 from both sides to get x by itself. So x equals 55 degrees. Okay, take a moment, solve this other one using the same method. Add the 3, subtract from 180 to find your missing angle. Okay, next we're going to talk about the exterior angle sum. These are the angles on the outside of a triangle. This angle is equal to the sum of the opposite interior angles. So we take this angle, it's equal to the sum of these two angles. Sum means we add. So here we go. This exterior angle equals the sum of these two. So we add them together. Means x equals 70 degrees. Right here. And the unit, the degree mark, is already on the angle here, so we don't have to write it again. In the green section, it was not already written there, so we had to write it. There was no degree mark already. Okay, we know the side opposite the largest angle or across from the largest angle is the longest side. And the side opposite or across from the smallest angle is the shortest side. So now when we want to arrange the sides from greatest to least, we need to first make sure we know all three angles. So I need to know this angle. Well, we'll use our triangle sum theorem. We know that the three angles add up to 180. So to find the missing angle, we can subtract these two from 180. So 180 minus 61 minus 32 means that this missing angle is 87 degrees. I'm going to mark that in my picture just so I don't forget. Now I want to arrange my sides from greatest to least, from largest to smallest. I know the longest side is going to be across from the largest angle, which is 87. That means our longest side is Z. And this is a capital Z. It needs to be capital. Capitalization matters. Our next side, our medium side, would be across from our medium angle. Well, between 61 and 32, 61 is larger, so this is our medium angle. It's across from side capital N. Finally, our smallest angle is across from our shortest side, and that would be lowercase e. Capitalization matters. If these are not capitalized correctly, I'm not going to give you credit for it. Finally, our triangle inequality theorem says that the sum of any two sides of a triangle must be greater than the measure of the third side. We want to highlight the side combinations that can form a triangle. Okay, so and we remember, when we're checking to see if it'll make a triangle, adding the smallest sides is the most helpful to us. So in this first potential triangle, 2 and 3 are our smallest sides. 2 plus 3, we know, is 5. That's actually not greater than 7. So this would not form a triangle. Because the sum of these two sides is less than the longest side, it would not be a triangle. Let's try again. 4 and 5 are our smallest sides. 4 plus 5 is 9. That is greater than 7. So it would be possible to form a triangle with these three sides. Next, 1 and 1 are our smallest sides. 1 plus 1 is equal to 2. It's not greater than. It has to specifically be greater than. Because these are equal, remember when we did that exploration, we saw that it fell flat and it made a straight line. So this would not make a triangle either. Okay, finish up with these three examples. And then don't forget to hit the submit button on your notes in Canvas so it turns it in. Make sure you finish the parts that I left for you, like this second example, sorting your other triangles. And do that before you turn it in. After you do this, you have your 4.3 Desmos activity. Part of that is practicing these properties. Part of that is learning about corresponding parts. I think you can get it from reading the slides, but there is a video just in case you need help on that assignment as well. Let me know if you need anything. Your 4.4 assignments are all extra credit. Those are optional. Let me know if you need anything else. Have a great day.